Hello everyone, this is Mrs. Snook with section 7.4, Matrices and Systems of Equations. And in this section I'm going to introduce to you matrices, and we're also going to be able to write matrices and identify their dimensions. We can perform elementary row operations on matrices just like we do on systems, and we can use matrices and Gaussian elimination to solve those systems. So here goes. First thing, a matrix looks like this. So you've got brackets on the side, and then inside the matrix, you'll have numbers. And then the dimension of a matrix is the number of rows in your matrix by the number of columns. So let's take a look at some matrices. Here's this matrix, just has a 2 in it. So it's got 1 row and 1 column. This is a 1 by 1. And remember, it's rows by columns. Here for B, we've got 1, 2, 3, 4. So we have 4 columns, but they're all in 1 row. So it's 1 row by 4 columns. C, now I've got 2 rows and 2 columns. That's the 2 by 2. And then D, I have 3 rows and I have 2 columns. So that's a 3 by 2. Last one, we've got 3 rows and we have 1 column. So 3 by 1. The easiest way to do this is just remember rows goes first. Okay, next idea is the augmented matrix. And this is where we start getting into solving equations with a matrix. So I want you to notice here that we have 3 variables. We have x, we have y, and we have z. And when we write an augmented matrix, each variable gets its own column. So I'm going to set up my bars. And in my first column, I'm going to put x's. My second column, I'm going to put y's. My third column, I put z's. And notice I also have a column on the other side of the equal sign. I'm going to put in a dashed line in here. And then on the other side of the equal sign, I'm just going to call those constants. Okay. So now what I do is I take the coefficient of my variables and I put that in the matrix. So my first equation, I have 1x. There's an invisible 1 in front of there, so I put a 1 in my first column. My second column is 3y, so I put a 3 there. There is no z, so that's like a plus 0z. So I put a 0 for my z, and then on the other side of the equal sign, I have a 9. Now let's go to the second equation. I don't have an x at all, so that's like a 0x. I put a 0 for my x. I have a negative y, so there's an invisible 1 in there, so that gives me a negative 1. And then for z, I have a 4. And negative 2 is my constant. That's a 4. No, it's not letting me write. There we go. And then my third one, I have x, so I have invisible 1. I don't have any y at all, so I put a 0. I have negative 5 for my z coefficient, so I put a negative 5, and my constant is a 0. And that's called the augmented matrix. And then it says, what are the dimensions of the augmented matrix? Well, I've got 3 rows, and I have 4 columns, so 3 by 4. So I want you to notice that while we have 3 variables, that means I should have 3 equations, so then I get 3 rows. I have 1 extra column, and those constants make up that extra column, so this is a 3 by 4. All right. Now we're going to do some elementary row operations on this matrix. So right here, it says interchange the first and second rows of this original matrix. So I'm going to call this one row 1, this one is row 2, and this one is row 3. And I'm using R's for rows. So since I want to interchange row 1 and row 2, I'm going to do like this. This one is going to be, row 2 is going to go here, and row 1 is going to go there. So that's how I'm going to note that. So here's what my new matrix will look like. I interchange the rows, so row 2 is going to go first, so -1, 2, 0, 3. Now the first row goes, so 0, 1, 3, 4. So you see I just traded their positions. Last row, make no change, so 2, -3, 4, and 1. Okay. Now the next one says multiply the first row of the original matrix by 1/2. So this row here is going to be 1/2 of row 1. So here's row 1, row 2, row 3. I'm going to draw my matrix. I'm going to take this first row and I'm going to multiply it by 1/2. So 0 times 1/2 is still 0. 1 times 1/2, that's 1/2. 3 times 1/2 is 3 over 2. And then 4 times 1/2 is 2. And then I don't make any changes to the other rows. So -1, 2, 0, 3, and 2, -3, 4, 1. That's how I do that row operation. Next idea is we're going to add -2 times the first row of the original matrix to the third row. So again, remember this is row 1, row 2, row 3, and I'm going to add -2 times the first row, so -2 row 1, and I'm adding that to the third row, plus row 3. And I do want you to write down this notation of what rows we're doing, so please include this information so that when I look at your work, I know what you're doing. Row 1, no change, so I'm just going to copy it over, 0, 1, 3, 4. Row 2, no change, copy it over, -1, 2, 0, 3. Now row 3, I'm going to do -2 times row 1 plus row 3. So I'm just going to write my work over here. I find it much easier to actually write down what I'm doing. So -2 times row 1, that's going to be 0, -2, -6, -8. And then row 3, that's going to be 2, -3, 4, 1. Now I'm just going to add them together. So 2, -5, -2, -7. And then I'm just going to copy these coefficients over. So 2, -5, -2, -7. Right, now the next thing to look at is row echelon form. And what row echelon form says is that in each row, your first digit is a 1, and that's called the leading one. So look right here, I got a 1 in the first row. Now my second row, I can have a leading digit also of 1, but it's got to be over to the right one. Or the way your book says it is the one on the top has to be to the left of the one underneath. And then same thing here, I can have a 1 there, and as long as I have these 1s coming down, making this diagonal, where the one above is one left to the one that you're looking at, then you have what's called row echelon form. Now reduced row echelon form, that's where you have these 1s, but underneath them all, like kind of filling in, are 0s under here. So this example right here is reduced row echelon form. Now let's look at B. All right, I have a 1 here. So that's my leading one in my first row. That's fine. Second row is all zeros. Now to be in row echelon form, if you have any rows that are all zeros, they're supposed to go to the bottom. So that means that it's not in a row echelon form. All right, let's take a look at C. So I have my 1 there. Next one over. That one's a 1, that one's a 1, that one's a 1. And you notice that we also have all of these zeros here. So that one is in row echelon form. And it's also been reduced. So we have here a reduced row echelon form. All right, now let's look at D. I have my row with all zeros, that's at the bottom. I have all 1s going across here, and I have all zeros. So reduced row echelon form. Now take a look at E. Again, we have a 1 there, that's our first term. And now take a look. If I look at my second row, my leading term is a 2, not a 1. Look at my third one, I have a 1. So this is not in row echelon form. It's close, but not there. And the reason is that 2 right there. All right, take a look at this last one. I have, here's my 1s. I have my row of zeros all at the bottom. I have zeros underneath. And my first leading digit here, that's not a 0, is a 1, and that's coming at the top. So this one is in row echelon form. In fact, take a look at these zeros under here. You could even say that it's a reduced row echelon form. Okay. Next up is we're going to solve this system with back substitution. And we're going to need a lot of room for this. So the first thing we need to do is write your augmented matrix. Okay, and then the next thing we're going to do is use row operations. And we want to do that until we get into a reduced echelon form. So we want reduced row echelon form. And then we're going to substitute. That's going to be our process. The first thing we need to do is write our augmented matrix. So here goes. I have X, Y, Z, and W. So I'm going to have 4 variables. So I'm going to have 4 rows. And then when I put my constants in, I'm going to have 5 columns. So first row, 0, 1, 1, -2. And I'm going to put those dashed lines in, and I get a -3. Second row is going to be 1, 2, -1, 0, and that's a 2. Third row is 2, 4, 1, -3, 2, 4, 1, -3, and then -2. Last row is 1, -4, -7, -1, 1, -4, -7, -1, and that's -19. All right, so there goes my matrix. And I'm going to start working on getting it in reduced row echelon form by using elementary row operation. And so what I notice right away is I have a 0 here and a 1 here. So if I swap those two rows around, then I will get a leading 1 where I want it. So I'm just going to go ahead and do that. Let me make sure I have my pen. So first thing I'm doing is swapping row 1 and row 2. So row 2, row 1, swap, and keep the others where they are. So 1, 2, -1, 0, 2. And then my first row, 0, 1, 1, -2, -3, and then keep the others as they were. Okay, so now I've got my first row has a 1 in the leading position, and my second row, now I'm going to check that one. So I've got a 1 here, I've got a 1 there, and I have a 0 right here, so that's good. So that means second row is fine. Now I'm going to take a look at my third row, and what I want for my third row is I want a 0 here and a 0 here. So I'm going to do some row operations to make that happen. And so what I notice is if I do -2 times row 1 and I add that to row 3, this 2 is going to cancel out and that 4 is going to go. And I'm just going to go over here to the side and I'm going to show you that. So my next operation is going to be -2 row 1 plus row 3. So -2 row 1 plus row 3. I'm going to do that. So -2 row 1 is going to be -2. -4, +2, 0, -4. And then my row 3 is 2, 4, 1, -3, -2. So I'm going to add those together, and I get 0, 0. I get a 3, a -3, and a -6. Okay, so that's going to be my next step. So I'm going to switch back to my other color. And row 1 is here, row 2 is here. I need to draw my brackets bigger. And then row 3 is going to be -2 row 1 plus row 3. And then we're going to have row 4 here. The other thing to keep in mind is just do one row operation at a time. So keep row 1 as it is. So 1, 2, -1, 0, 2. Keep row 2 as it is. 0, 1, 1, -2, -3. And then put this in 0, 0, 3, -3, -6. Row 4, keep it as it is. 1, -4, -7, -1, -19. So I'm not quite done with row 3 because I have a 3 here instead of a 1. So what I'm going to do to make that a 1, I'm just going to divide it by 3. So my row 3 is now just going to be my old row 3 divided by 3. So row 1, 1, 2, -1, 0, 2. Row 2, 0, 1, 1, -2, -3. Now row 3 is going to be 1/3 the original row 3. So 0, 0, 1, -1, -2. And then row 4, I'm leaving as it is. And I have 1, -4, -7, -1, -19, and there's my little dash line. All right, so let's check. Row 1 is fine because I have 1 as my first number there. Row 2, I have a 0, then a 1. That's fine. Row 3, I have a 0, 0, and then a 1. That's fine. So now I have to figure out row 4. So now I'm going to go on to row 4. Right, so what I'm going to do is I'm looking and I see I have a -4 here, and I want to use this row 2 here because I've got a 0 and a 1. If I was to multiply this by a +4, then I can cancel out this 4. So I'm going to copy 1, 2, -1, 0, 2, 0, 1, 1, -2, -3. And then I have 0, 0, 1, -1, -2. And I'm going to take care of that -4. So what I'm going to do is I'm going to do row 4 plus 4 times row 2. So row 4 plus 4 row 2. Actually, no, let's wait a second. I have this 1 in here. So what I'm going to do is row 4 minus row 1. I'm going to take care of that 1 first. So row 4 minus row 1. Row 4 is 1, -4, -7, -1, -19. And I'm going to minus row 1. So -1, -2, +1, 0, -2. Add those together, I get a 0. I get a -6, another -6, -1, and a -21. So 0, -6, -6, -1, -21, and I'll put in my dash line there. All right, now the next thing I need to do is, since I've got the 0 here, I need to remove this 6, and I'm just going to add 6 row 2. That's going to take out that 6 for me. So now row 4 plus 6 row 2. So here's row 4, 0, -6, -6, -1, -21. 6 row 2, 0, 6, 6, -12, -18. So I'm just going to copy over my first 3. Now let's go ahead and finish this. So I get a 0 there, I get a 0 there, I get a 0 there, I get a -13 there, and -39. So let's put in our numbers. So 1, 2, -1, 0, 2, 0, 1, 1, -2, -3, 0, 1, 1, wait a minute. Then 0, 0, 0, 13, -39. Double checking, we have a 1, 0, 1, 0, 0, 1, 0, 0, 0, 13. I need to turn that into a 1. The best way to do that is to divide by 13. So now what I'm going to do is I'm going to take that last row, row 4, I'm just going to divide everything by 13. So we have 1, 2, negative 1, 0, 2, 0, 1, 1, negative 2, negative 3, 0, 0, 1, negative 1, negative 2. And then I'm just going to divide this last row by 13. So 1 over 13, row 4. So I get 0, 0, 0, 1, negative 3. All right, I am now in my reduced row echelon form. So I'm ready to back substitute. So using my back substitution, I know right away that W equals negative 3. Just as a reminder, this is the X column, the Y column, the Z column, the W. So 1W is negative 3. So that's our first answer. Now I've got Z plus W is negative 2. But I know W is negative 3, so Z minus 3 equals negative 2. Z equals 1. Okay, so now I've got Z. Go backwards again. I'm going to go up to the next one, which says Y plus Z minus 2W equals negative 3. Y I don't know. Z is 1. W is negative 3. So I'm just plugging in. So I get Y plus 7 equals negative 3. So Y equals negative 10. And then lastly, I'm going to plug in and get X. So that's X plus 2Y minus Z equals 2. So X plus 2 times 2 minus 1 equals 2. X. So X equals negative 1. So here's my answers. And that is the end of this lesson. Thank you for watching and have a great day.